Hello everyone. Today we will discuss the observability for the control system. What is the concept we are trying to develop? We are trying to establish the concept for the observability. However, in the previous video, you may see we have discussed about the controllability and the different controllability criteria. Sorry. So we have discussed the Kalman test. Well, first of all, we have established the concept of controllability, and we have seen if definition of the countability, where we have discussed that if the system, you can say, if your input is able to steer all the state variables, then you can say that the system is stable, sorry, controllable. Or if it is not possible, then you can say this is a uncontrollable system. So this is a basic definition. I am repeating once again. So if your input is able, let's say this is ut, is able to state, or you can say steer, or you can say derive all the input, all the state variable, then only you can say that the system is controllable. So we already have discussed, or my request to all the students, if you have not visited or you have not revised that controllable, what is the controllability and what are different criteria. So it is my request to all the students, please go through first, revise that, and then only you can understand the concept of, you can say that it will be very easy to understand what we will study today, that is observability, and also what we will discuss in the future lectures, that is that is your state observer, you can say the designing of the feedback control, how the feedback control is going to design. So that depends on the parallel decomposition, Jordan canonical form, controllability, and different types of uh, uh, you can say the criteria of the controllability, what are the fundamentals of for this all these things. So being sure you all knows these concepts. If you're not visited or you have revised, so it is my again request to all of you, you can find out my playlist Modern Control System by the name of the Modern Control System in the YouTube by Dr. Prakash Verma, and you can revise. Okay, so I am just starting here. I will try to build up the concept of the observability. So you can see here I have drawn two figure 1 and figure 2. Okay, figure 1 and this figure 2. So in figure 1 you can see this is the parallel diagonal canonical form. Okay, so diagonal canonical form of such type of system, it is nothing but this is the integrator, and there is some feedback. This is the lambda 1. Okay, and this is the negative side, and such type of system will be represented, and these all this by solved, you can say that this is a block, this is represented a single block, that is 1 upon s plus lambda 1, right? Okay, so we already have discussed these things. It's the same can be represented here like this one. Okay, so 1 plus 1 upon s plus lambda 1 k1, the second is the 1 upon s plus lambda 2, and similarly all these things. Sorry. Okay, so the output for this diagram figure 1, you can write here y t is equals to whatever this k1 x1s, ys is equals to, I'm writing y is equals to x1s into k1s, x2s into k2s, and x3s into k3s, right? And what is s1s? S1 is nothing but 1 upon s plus lambda 1 into ui, whatever the us, the step response or Laplace of this one, ut. Okay, so y is equals to, we have written k1, k2, k3 in the matrix form, the vector form x1, x2, and similarly you can write y is equals to kx or k1, k2, k3x, right? And most precisely we can write here y is equals to kx, nothing. Okay. So in the second figure, the important part is here. You can see the one state variable, that is the x1s, is not connected with the output. This is not connected. This is the absent. This is disconnected. Okay. And therefore you can't be able to estimate the variable, state variable x1s from this output. Or you can say you are not able to find out the x1s with the help of the measurement of ys output. Okay. So it means the output equation for this figure 2, you can write here y is equals to only k2 k3 into x, but not k1x. Okay, because this is disconnected. And therefore the concept is here, as we have discussed in the controllability, the input is just steering all these state variable. Here the output is, if you are able to find out the state variable with the help of output, then you can say the system is observable. The main concept, the main idea, the main concept is this one. Okay. So here, just what we have discussed here, I am just summarized, okay, so that you can clearly write. It means we are going to define the observability definition with the help of this line. The ability, okay, the ability to estimate a state variable, estimate a state variable from the known output, right, from the known output, and input is known as observability, right, observability of a system, of a system, right, of a system, right. Okay. So by this way you can say that the figure 1 is observable. However, the figure 2 is non-observable or completely not observable. You can say this is observable, this state is observable, this state is observable. However, the x1s is not observable, so you can say this is the not completely observable, right, right. Okay. So it means you have concluded here figure 1 is is said to be completely controllable, is said to be completely controllable. However, figure 2 is not completely controllable, vice versa, right? Figure 2 is said to be not, or can say is not completely, right, controllable, right, controllable. Okay. Now coming to the next idea, that is, how it is defined. So what is the definition? If anyone asks you, so you can say that a linear system represented by a state model, and that state model is here. What is x dot is equals to ax plus bu, whereas y is equals to cx plus du. You can define here is completely observable, if and only if all the state variable can be, uniquely determined. Yes, uniquely determined using the input ut and output yt, right? Otherwise, the system is said to be non-observable. Otherwise, the system is said to be otherwise system is the system is said to be unobservable. Unobservable. I hope the concept is very clear. Okay. So now the question is, as we have discussed in the controllability, the matrix involved for deciding the controllability is, A square B and so on, right? That is the color matrix we have decided, model matrix. Okay, we have determined the model matrix for this purpose. Okay, first, if anyone asked define the find out the controllability of this equation, this state model, then you have to build. First, you are building the the model matrix, and model matrix is nothing but the B, and A square B, and A to the power n minus 1B, right? So A and B matrix, this means the input matrix was responsible in order to find out the state variables, and therefore the A and B were involved in order to find out the controllability. However, in this case, therefore I'm repeating in every lecture. Please go through the previous videos so that you can understand, you can memorize these concepts. Okay, so okay, so here in the observability, in the observability, the output will decide. Okay, the output will decide, the state of the output will decide the state of uh, equation, state variables. So the equation here is involved, the matrix involved for this one purpose is A and C. Okay, so I'm just writing here obs observability is a property of the coupling between the state xt and output yt. You are going to find out the state variable with the help of the output. Okay, and those involve the matrix simply A and C. We will see in the Kalman test also. Okay, so this is the basic definition. Okay, in the next video we will discuss the observability criteria. And what are the different criteria for this? We have already discussed Gilbert test for the observability criteria. Then, and in this we have the two cases. First is the not for the repeated eigenvalue, not repeated eigenvalue. You can see simple eigenvalue is there. Okay, and for the second case we will we establish the concept for the repeated eigenvalue, right? Repeated eigenvalue. Then the second method is the Kalman test, and then we will discuss the factor cancellation method, factor cancellation test, and last one will be the PVH, Popo Balevich Hautus theorem. PVH, Popo Balevich Hautus test, right? So in the upcoming video we will discuss the Gilbert test, Kalman test, factor cancellation, and PVH in more detail. So summary is this one, summary, or we are just concluding. What is, if anyone asks you what is the observability, then it means simple. If you are not able to find out the state variable from the output, then you can say the system is not observable. Okay, not completely observable, because in that state model maybe it is possible the other state variables is attached to the output of the system, and that state variable can be determined. Okay, so you can see from the figure 2, the first state variable lambda x1 is not able to you can find, and therefore it is a non-observable. Thank you.